I request the viewers, please like and share my videos and subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the section Complex Analysis, and this question has appeared in the CSIR National Eligibility Test held in July month of 2024. The problem is related to the Laurent's expansion of a function about a given point. The problem is from the part C. It is a multiple select question. There can be more than one answer. It carries 4.75 marks. The question ID is 704080. This question is suitable for the aspirants of the JL, DL, TS set, AP set, IIT JAM and GATE. The given question is for Z belongs to C minus singleton 0, that means Z is a non-zero complex number. Let f of Z is equal to 1 by Z sin of 1 by Z and g of Z is equal to f of Z multiplied by sin of Z. Which of the following statements are true? We are given four options. Option 1, f has an essential singularity at 0. Option 2, g has an essential singularity at 0. Option 3, f has a removable singularity at 0. And option 4, g has a removable singularity at 0. Let's now discuss the solution of the problem in detail. We take first the function f of z is equal to 1 by z into sine of 1 by z. Right. And if you see f of z, it is analytic everywhere except at z is equal to 0. Since z is equal to 0 is the only singularity of the function f z, it is an isolated singularity of f z. Right. So now f of z is equal to 1 by z into sine of 1 by z. Let us write down the Laurent's expansion of sine of 1 by z about z is equal to 0. It is well known that 1 by z into sine of 1 by z is 1 by z minus 1 by z cube into 3 factorial plus 1 by z to the power of 5 into 5 factorial minus so on and so forth. Now, what do you observe? We observe there are infinitely many negative powers of z that are present in this expansion. So, the part of the Laurent's expansion which contains the negative powers of z is called the principal part of the Laurent's expansion. So, its principal part contains infinitely many terms. And when it contains infinitely many terms, z is equal to 0 is an essential singularity. And once this z is equal to 0 is an essential singularity, z is an isolated singularity, and z cannot be a removable singularity. Right. So, thus the option 1 is true and the option 3 is not true. Let's move to the next slide for the discussion of g of z. Right. And we have already seen option 1 is true and option 3 is not true. Now, secondly, we have g of z is equal to f of z into sine z. F of z is 1 by z into sine of 1 by z into sine z. So, g of z is analytic everywhere except at z is equal to 0, and it is an isolated singularity. Now g of z is equal to 1 by z into sine of 1 by z, expansion written as earlier, into, for sine z we have written z minus 1 by z cube by 3 factorial plus z to the power of 5 by 5 factorial minus so on and so forth. Now multiply this 1 by z with this sine z expansion, then you will get, this is the negative powers multiplied by 1 by z into z, 1 minus z square by 3 factorial plus z to the power of 4 by 5 factorial minus so on and so forth. Now you simply multiply all this with 1, just with 1. Let's see what do you get. So you are multiplying all this bracket with 1. So you will get 1 by z minus 1 by 3 factorial z cube plus 1 by 5 factorial into 1 by z power 5 minus so on and so forth, and many more, some more negative powers of z will come, then the positive powers of z also will come. The principal part is that part which contains the negative powers of z. Therefore, the principal part contains infinitely many terms. Therefore, z is equal to 0 is an essential singularity of gz, and when z is equal to 0 is an essential singularity, it cannot be a removable singularity. When it is a removable singularity, the Lorentz expansion will not have the principal part at all. But it is the principal part that is available abundantly, therefore it cannot be a removable singularity. So the conclusion is option 2 is true and option 4 is not true. Option 4 is not true. So combining these two, so option 1 is true and option 2 is true. The answer to this question is option 1 and option 2. That is the detailed discussion of the solution of the given problem, which is based on the concepts of Lorentz expansion, and it is definitely an easy question. I am sure that you have understood the solution of this problem, and I make a request for all my viewers who are watching my videos. Please like and share my videos and subscribe my channel if you have not already subscribed. I wish you all the best. Thank you.